Hey everybody, my name is Dalton Cole. I'm the Chief Technology Officer at Digital Opportunities Group. We're an asset management firm that specializes in digital assets. And today I want to talk about Bitcoin supply math, how we know how many Bitcoin will be created. Most people that are familiar with Bitcoin know that it's about 21 million. Those same people might tell you that the last Bitcoin is going to be mined in year 2140. But what a lot of people don't realize is that neither the number 21 million or the year 2140 are actually hard coded into the Bitcoin's core code. So the only thing that actually controls Bitcoin supply is get block subsidy, which is a function in the Bitcoin code that rewards miners whenever a new block is mined. So when a miner mines a new block, they get both the transaction fees that Bitcoin users pay to process transactions, but they also are subsidized with the get block subsidy. And what get block subsidy does is it takes the height of the blockchain, so essentially the number of the most recently mined block, and then it also takes in the consensus params, and it takes the subsidy halving interval, which is 210,000. So that means that the subsidy is halved or cut in half every 210,000 blocks. And the starting subsidy, which is in subsidy here, is going to be 50. So 50 Bitcoins times the most atomic unit, which is the 100 million Satoshis that are in each Bitcoin. So each Bitcoin is divisible up to 100 million tiny pieces, and those tiny pieces are called Satoshis. So essentially we start out with this, and then it's halved every 210,000 blocks, and then that resulting number is returned. So if we were on block number 1, we would get 50. It's never halved because it hasn't hit the 210,000 block yet. So the returning in subsidy would be the 5 billion Satoshis. That would be the 50 Bitcoin times the 100 million atomic units. So we're going to dive into this code. I made a little Excel workbook that'll help explain this a little better. But yeah, just to walk back through the code, we have the number of halvings, which it takes the height of the blockchain, so essentially the number of the most recently mined block, divided by the halving interval, which is 210,000. So every 210,000 you get a new integer, which is one higher than the previous. Because these are integers, there's no decimals. If this returned a decimal number, you would actually see more of a steady curve in Bitcoin supply, but you'll actually, or in the way that the actual Bitcoin rewards are generated. So it would actually look like a curve like this, because you would have decimal places that would help round that down. But because halvings are returned in an integer, you actually have a stair step effect to it. We also have this interesting line of code here where if the halving is greater or equal to 64, return 0. So that's going to say give you 0 rewards. If the halving is greater than 60 or greater than or equal to 64. That line can be a little confusing because you actually stop getting rewards after the 33rd or 32nd halving technically. I'll explain that in just a second. But yeah, it's really simple code. You get the halvings, and then you essentially have the 50 Bitcoin for each number of halvings that have happened, and then that is the subsidy, and that's the only way that Bitcoin can be created. And we'll show you how that gets you to 21 million. So here we have a little simple binary calculator I made. So this is actually how the number 5 billion is generated in binary. And how did I get, and I've highlighted the ones in green just to make them a little more noticeable. So how did I get the 5 billion? As I mentioned before, it's the 50 Bitcoin times the 100 million, which is this number, the amount of Satoshis in one Bitcoin. So that's the number of atomic units inside one Bitcoin. So that times that gives you 5 billion. Okay, so we started with 5 billion, which is this number in binary. I've created a little simple binary calculator. If you're not familiar with binary, you can look it up or just trust me. Don't really have time to explain how all that works. But essentially, this is halving. There has not been a halving yet. The start block starts at block 0 all the way up to the one before the 210,000 block. So for every block that is mined there, the miner gets 50 Bitcoin, which is quite a bit of money these days. Back then, it was not as much. And then I'm also calculating how many Bitcoin were mined per halving. So a lot of Bitcoin were mined in that halving. And then when we get to the 210,000 block, that'll be the first halving. So that would be 210,000 divided by 210,000 will give you 1. So that's halving number 1. And the way that halvings, or that the rewards are calculated here, it's called a right bit shift. So for people who aren't familiar with the way that works, is it actually takes the binary number and it shifts it one spot to the right. So another way to think of this, I've actually got a different calculator over here, and the math that I'm using is we would divide by 2 to the number of halvings. So in this example, you have 3 halvings, and we divide by 2 to the power of 3, which actually comes out with the same number as if you were to shift a binary number to the right 3 times. So each time this number is shifted to the right, so when we take this and we move it 1 over to the right, you can see that we're starting to drop zeros here at the beginning. If it doesn't have that, so this is 64-bit. If a 0 is not there, it's interpreted as a 0. But you'll see as we start to shift these numbers to the right using the right shift operator in C, the number of rewards gets cut in half. So we go from 5 billion. After the first halving, it's 2.5 billion. After the second halving, it's 1.25, all the way down to where we are currently, which is 625 million satoshis per block, because there's 100 million satoshis in each Bitcoin. Each block mine gives you 6.25 Bitcoin, so that's kind of the era we're in right now. The most recent block is, I think I've got it written here, 776,527. So that's going to put us right inside this range here. And then when we get to the 840,000, which I think somewhere around 2024, it'll be the fourth halving, and then Bitcoin rewards per block will go from 6.25 to 3.125. So, and that steadily happens about every 4 years, and I'll get into that in just a second. But as you can see, once we get down to the 32nd halving, we only have 1 bit in the ones place in binary, so that represents a 1. And so that's the last time that you'll actually get a valid Satoshi. You can't have less than a single Satoshi because that's the most atomic unit. And so you have 1 Satoshi that's mined per block. So 1/100 millionth Bitcoin is rewarded per block. And the amount of total Bitcoin minted across this last halving is well below a single Bitcoin. And after that, because we've shifted to the right, one more, no more Bitcoin are created after this point. And if we sum up each bucket of Bitcoin that are created in each halving era, I sum them up down here, and we get a little less than 21 million. Some Bitcoins lost forever. People lost their keys. There was some Bitcoin that was being tested with. It's all locked up. The first 50 Bitcoin, I think, from the Genesis block is unavailable. So the number's a little bit slightly less than that, but that's where the 21 million comes from. And yeah, what's the next? Oh yeah, the amount of time. So we've got the 21 million. How did we get to the fact that there's a year 2140? And that's just based off of the fact that there's average block mining time is about 10 minutes. So if we take our current block, 776,527, and we get the last subsidy block, so that's going to be this block is the last block that will actually generate a subsidy. We subtract what block we're at from the last subsidy block. We get this many blocks to go until there's no more subsidies. And then what I've done here is I've multiplied the amount of blocks by 10 because it's 10 minutes. I've divided by 60 to get the number of hours, divided by 24 to get the number of days, and divided by 365 to get the number of years. And that's how we get up to 117 more years until we run out of Bitcoin or no longer minting new Bitcoin. And that's how we get to 2140. So if we take 2023, current year, and add 117, we get 2140. Okay, oh, one more thing. Right here, this line of code. So if the halvings is greater than or equal to 64, return 0. So then it will not run this math. It will not tell you, it will not run the right shift operator. It will just return 0 as the subsidy. And why does that matter if we start to get 0 at this point on the 33rd halving? And that's because once you get to the 64th halving era, even though we haven't generated any Bitcoin for the last, I don't know, this is probably a couple hundred years, or 100 years probably, I guess, is because you're still shifting right in this math. So even though this code is, we know from 33 and beyond, will not generate any output, at line, or once we get to 64, we can no longer shift this number to the right anymore, because there's no more places to shift it. So it will start to return an error or an undefined value. So they've just said if it's 64 or greater, just return 0. They probably could have done the same if it was 33 or greater, but they chose 64 because that's when the error will actually occur. So yeah, that's all that controls Bitcoin. So if miners all agree and the core developers were to change this to return any number that isn't 0, and it could be a static number, then you would actually have an infinitely growing Bitcoin supply if things ever need to get to that point. But as of right now, 21 million comes from that 10 lines of code, and this is how they use the right shift bit operator to have it every 210,000 blocks. So the only numbers coded in here are 210,000, the amount of satoshis, and then through some of the mining logic is how we get to the 10-minute average, which is essentially what tells us how long it's going to take. That doesn't have an effect on total supply minted, but does kind of help us gauge how much time is left. Thanks for watching.